Started. I see Ritika is missing, but hope she'll be joining soon. Okay. Alright, so let's resume from where we had left it. So yesterday we were talking about circle theorems. So there are 7 theorems with circle, and that is what we will continue with, and we'll try finishing it today. While we're waiting for Ritika and Dave to join. And Arya is also missing. Where is Arya? Sorry, Aryan, not Arya.
I might need a reminder. 1 second.
Okay. Ritika is here now, so we are only missing Aryan and Dev. Okay. So basically, we were talking about circle theorems. There are total 7 theorems for circle that we're going to go through, and then we'll try proving them. It's just not about me asking you guys to memorize it. So let's look at the circle theorems one by one. So you guys have to remind me to buy markers. My markers are running out of ink now. This is the circle, and this is the radius. Everybody knows area equals pi r square, perimeter equals 2 pi r, and then we talked about what is an arc and what is a sector and what is a chord. So if you pick up 2 points on the perimeter of the circle, if you join these two, this is called chord. If you look at the curve here, then this is called arc. And then if you join this with the center, this area is called the sector. Area of the sector. Now let's look at the theorems one by one. So one theorem that we proved yesterday was this one, that if I have a circle and pick 2 points on the perimeter, if you join these 2 points, then it makes an angle here on the center. This is which you call center angle. And then the same 2 points, if you pick any point on the perimeter, join this angle will be half of this angle. That's what we proved yesterday by kind of joining these two, and then finding that these two are isosceles triangle. This angle and this angle are same, and this angle is half of this angle. So and similarly this angle we proved as half of this angle. So sum of these two angles is twice of these two angles. That's what we proved yesterday. Let's look at the other theorems, and we'll go through that one by one. So everybody recalls what we discussed yesterday, correct? Whatever theorem I mentioned on this, and I showed on the board, you guys are able to recall that, correct? Okay, I'm assuming that is a yes. Now, okay, so the next theorem says that if I and keep stopping me if I'm going fast, if there is something that you're not able to follow. Don't assume that teacher is always right. If there is a doubt, don't hesitate to stop me. So this is a circle. What the second theorem says is, if you have a chord, okay, meaning you have picked 2 points on the perimeter, this is a chord. This chord makes, if you use the same 2 chords, okay, and pick any point on the perimeter on one side, this angle and this angle will be the same. This is the second theorem, which says a chord makes any angle on the, you pick this chord and pick any point and join that point with both the ends of the chord. This angle will be same. Now the thing is, how do we prove this? Let's look at this. So we have a circle. We are saying this is my chord, meaning we have picked 2 points on the perimeter, and saying if I pick these 2 points and join the points with the ends of the chord, then we see these angles and these angles. This theorem says these two angles are same. Now you'll say, how? Let's try proving it. So what you have to do is pick the center of the circle, okay, and join this center with the two ends of the chord as well. Now so let's give it a name. This is AB is my chord, C and D are the 2 points where I'm plotting two angles, and let's say O is my center. Okay. The first theorem that we saw just now was the angle made by the chord on the center is 2 times the angle made on this by the same chord on this one. Meaning, by the first theorem that we just saw a little bit ago, where if you have this circle and so this angle made by this chord on the center angle is twice the angle, twice of this angle, right? That's what was the first theorem. That means if you relate it here, angle AOB, this is the center, this will be 2 times this angle, meaning it will be 2 times the angle ACB. And same way, if you look at this chord, I mean this angle made by this chord on point D, again, and relate that to the center. This is same arc, same chord making the angle on center, and the same thing is making the angle on the point D is equals to 2 times the angle ADB. So what you see is the angle made by this chord on this center is 2 times the angle made on this point as well as on this point, like we saw in the first theorem. So that means this angle is 2 times this angle, and this angle is 2 times this angle also. That means these two angles are same. So what this theorem, what this theorem means always is, if you have any circle, pick any chord AB, you can pick as many points you want to find on the perimeter on the same side of the chord, okay? Make sure that you are picking it here, below this. And then if you join this versus you join this versus you join this versus you join this, all these angles will be same. The angle made by the chord on one side of the circle on any point on the perimeter will be same. That's what the second theorem says. So before I go further, are you guys able to relate to what I'm saying? Yeah?
Yeah.
Okay. So this is the second theorem. Let's go to the next one. And these are like fun exercise, okay? I mean, it's there's nothing new that we are learning. We are just relating to what we know already. We are just finding some creative ways. This theorem says, okay, fine. If you take a chord, the angle that it makes on the center is 2 times the angle made on this side of the perimeter. We are just relating that. We are saying, okay, we are just extending that information, saying, okay, fine. That means, any place I take, if this theorem is correct, then the second theorem also holds true. Yeah? Neil, Sarah, Chris, Vaibhav, everybody with me?
Yeah.
Here, Ritika?
Yes, sir.
Okay, I'll keep putting you guys on the spot, okay? Just to make sure that I have concurrence from everybody. It should not be theorem for me, it's for you guys. Yeah? Ananya, you are with me?
Yes.
Okay, alright. Now, the next one says, if you have a circle and pick any chord, this is your center. This theorem says, if you draw perpendicular from this point onto the chord, that bisects it. Meaning, if you draw perpendicular, let's say if you take this chord and draw perpendicular on this chord, this bisects it. this and this side will be same. How? Again, remember the four theorems of congruence that we talked about, that we just did a recap of. S, 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 A, S, A, S, A, and RHS. RHS holds true for right angle triangles. Yep.
So do you draw the perpendicular line from the center? So
Yeah. So basically, if you are drawing a perpendicular from the center onto the chord, this theorem says any perpendicular drawn from the center to the chord bisects the chord, meaning it splits into two equal parts, and that's what we are trying to prove. Let's say this is your center O, and you are drawing a perpendicular, meaning this is 90 degree and this is also 90 degree. Okay. This says, the theorem says AD will be equal to DB, and I don't believe that. We are trying to prove it, just to be sure about it. Simple thing, join these points as well. Now you have two triangles. Triangle OAD, this one, and then triangle ODB. So triangle OAD and triangle OBD. If you look at these two triangles, this side is common, okay, in both the triangles, okay. Now look at this and this, both are radius of the circle, yeah, and this angle is 90 degree. So here what you see is one side matching, this side is anyways common. What does this theorem say? For a right angle triangle, if hypotenuse and one of the side are same, they are congruent, meaning they are exactly a copy of each other. Here, this is the hypotenuse, which is also the radius of the circle, and radius is always the same. So hypotenuse is matching and this side is common. This theorem holds true. So that means these two triangles OAD and triangle OBD are congruent. Yeah. When they are congruent, meaning they have all the same properties, meaning the other side, the missing side, they will also match. So that means AD will be equal to DB. The area will be the same. This angle will be equal to this angle. This angle will be equal to this angle. We anyways don't need to prove that. What we wanted to prove was, if I draw a perpendicular from the center onto the chord, that equally that bisects the chord, that splits that into two equal parts. So going forward, if you ever come across a situation where you have a circle and you have a chord, even if this chord is a tiny chord, okay, and you draw a perpendicular from this one, you can be just assured that this is splitting into two equal parts. And how? We saw that. We just joined these two corners, these two edges of the chord. This gave us two right angle triangles. Hypotenuse is same, this side is common, and that's more than enough for us to prove that the congruence for these two triangles. If the triangles are congruent, that means the other sides will also match. Every other property will match for these two triangles. Are you guys with me so far?
Yes, sir. Yes, sir.
Able to relate?
yes, sir.
Okay, wonderful. Let's go to next one. Next one says, okay, angle of a semicircle is 90 degree. This one says the angle in a semicircle is 90 degree. Meaning, if and these are going to be real quick. I mean, if you know the concept, we can relate it very well. It says angle in a semicircle, meaning this is bisecting this. This is the diameter, which is splitting the circle into two parts. It says angle in a semicircle will be 90 degree, meaning this angle will be 90 degree. That's what it says. Or you pick any point here. Let's say you pick any point here. This will be 90 degree always. Or any point here, 90 degree. All this will be 90 degree. Why? Because the first theorem says the angle made by the chord on the center, the center angle is 2 times the angle made on the other side on the perimeter. Now this angle is a straight angle, 180 degree. This is 2 times of any angle here. Any point you pick up. So you have a circle, you have this diameter which is splitting this into 2 parts. Any point you pick up on the perimeter, just join it. This angle has to be nothing other than 90 degree. Because this is an angle made by the chord on the center, which is 180 degree, and this is going to be half of it. That's the first theorem. Is everybody able to relate to what I'm saying?
Yes, sir.
Okay.
Yes, sir.
Okay, wonderful. And let me ask a very dumb question. Had you guys got a chance to see how these theorems are proved in the past, or there's something new? And it's okay to if it's new, because I mean that I take a pride in teaching you or something. Yeah. Had you seen it, how those theorems are correct, how those theorems are to be validated? What does the thumbs up mean, Vaibhav? You have proved it before, or you're liking it being proved now?
Yeah, I'm liking to prove now.
Okay, wonderful. Okay, see, that makes me happy. All right, let's go to the next one. Next one says that is cyclic quadrilateral. Okay, the opposite angles in a cyclic quadrilateral total 180 degree. That's the theorem. Now, what does it mean? If I have a circle and I pick 4 points on the perimeter, join them. This is a circle and this is a quadrilateral inside that. This is called cyclic quadrilateral. Inside the circle, it's called cyclic quadrilateral. Says opposite angles of in a cyclic quadrilateral is, sum of the opposite angles in a cyclic quadrilateral is 180 degree, meaning this, if this is A, this is B, this is C and D, it says angle A plus angle B will be 180 degree. Angle C plus angle D will be 180 degree. Now you will say what? Same theory. Same theory. What you can do is find out the center. Or let me not do that. Let me make it even simpler for you guys. This is my center. No. Okay. I will join the. Okay. Let me join this. Now you look at. I can draw a better picture actually. That will make it look easy. Yeah. Okay. Yeah. I should draw a bit better pictures to make it look easy for you guys. This is a circle. I'm picking up 4 points. Okay. I'm joining the 2 edges. Now, this is not a straight line. Okay. Let's assume. Let me put a center somewhere here. Okay. Now, look at this. From this side, if you see, this angle is 2 times this angle. Yeah. And this angle is 2 times of this angle. Yeah. So this angle plus this angle is half of this angle plus this angle. Yeah. So if you look at from this side, from below, I mean, if I'm looking from down here, this angle is 2 times of this angle, and this angle is, if I am looking from the top, this angle is 2 times of this angle, and this angle plus this angle is how much? 360 degree. Yeah. So what we are finding from the first theorem is this angle is double of this angle is double of this, meaning these two angles together is half of this. So if this is A and this is B, A plus B, angle A plus angle B is half of the angle made here on the center, which is 360 degrees. So that means sum of these two angles is 180 degree. This is what the theorem says. And again, there is nothing new that you are seeing here. We are just correlating it with the first theorem by pictorially putting it on the board and then relating that first theorem. So essentially, so far we have learned only one theorem. Other theorems are basically related to that. Are we all good so far?
Yes, sir.
Yep. Shravya, are you with me so far?
Yes, sir.
Yeah, and you guys might not find me creative. I just randomly pick names, okay? There's no reason, no intention, no thoughtfulness behind calling out any name, okay? I'm just trying to make sure that everybody in the class is with me, okay? Alright. Now the next one is, next theorem says, so this is funny, okay? I put glasses to see things better. Now with age, I can see better without glasses. So that's why I keep taking out my glass. Okay. This one says a tangent of a circle. The angle between a tangent and a radius is 90 degree. This has two parts. Okay. Angle between a tangent and the radius is 90 degree. And next one says the tangent which meet at the same point are equal in length. Now this is a circle. I am picking 2 points. Okay. So this one says the first part of this says the angle between the tangent and the radius is 90 degree. Meaning these are my 2 points. Let's say A and B. It says this is my tangent. Let's say this is my second tangent. So tangent is like, this is, first point says tangent makes the angle 90 degree with the radius. This one is not a theorem to be proved. When you're talking about a tangent, you're essentially talking about on that point drawing a perpendicular line. So the first part don't have to prove. What it says is, second part says, if there are two tangents meeting at a point, they are same in length, meaning this one is equal to this one. Yeah. So let me read the theorem for you guys so that I don't find opportunities to confuse you guys. It says the angle between a tangent and a radius is 90 degree. Angle between a tangent and a radius is 90 degree. This one is not to be proved because that is how you draw a tangent. So this is the radius, second radius, and this is making 90 degree. This is the first part of the theorem. Second one says tangents which meet at the same point are equal in length. Meaning tangents which meet at the same point are equal in length. Meaning if the tangents are intersecting each other somewhere, I mean if you would have picked two points here and we would have drawn tangents, right? They would have met here. We picked these two, they are meeting here. Now it says if they are meeting at one common point, then they are same length. This one is this. Let's say this is O and this is, let's say, C. So what it says, this theorem says is AC equals BC, and that is what we have to prove. Again, no big deal. Just join the center with this point. Now what do you see? This is a right angle triangle. This is a right angle triangle. Meaning triangle OAC and triangle OBC. These two are right angle triangles. Both are 90 degree. Now We have to just find out that this one and this one are same. And that is clearly visible here. When you have right angle triangles, then the theorem that you use for congruence is RHS, which says hypotenuse and one of the side, if they are same, then the triangles are congruent. Here this is your hypotenuse because this is opposite to the 90-degree angle. Same thing, this is your hypotenuse for this triangle also. AOC and BOC. This is the common hypotenuse for both of them. Hypotenuse is already same because it's the same common line. And then this and this are same because both are radius. So hypotenuse and one of the side are matching, are of same length. That means they are congruent. And if they are congruent, then AC will be equal to BC. No denying that. Yeah. Shinarka, are you with me?
Yes, sir.
Ananya, any confusion?
I think I'm a little dumb. I don't get it.
Okay. No, again, never ever say that. None of us are dumb. We know something versus we don't know something, depending on what we have done in the past. Meaning, if we have come across this problem in the past, then I can solve it. If I have not come across this, I cannot solve it. So that's again, you guys are giving me a reason to talk about my theorem tran, right? I know some of you will not like it. I'll still say it. The first part of math is T. None of us should have any doubt with our trust. Meaning, I can do it. Okay? So, keep that key with you always. Okay? Everybody, including me. The day I start believing that I cannot solve it, I will not be able to solve it. Given. That is given. Okay? Now, coming back to this one. So, Ananya and everybody, Neil, Sarah, everybody, okay? Just pay attention for next 5 minutes. The first theorem that we proved was this, that if I have a chord, meaning 2 points on the perimeter of a circle, the angle that it makes on the center is double of the angle it makes on the perimeter on the other side. If I am looking at from here, I am going to pick up any point on the other side of the chord. Okay? If I am looking at this angle, I can pick up any point on this side of this side of the chord. Now, this is the first theorem that we saw. Now here, in this theorem, what it says is, if I have two tangents at any 2 points on the circle, if I have a circle and I take any 2 points, okay, and draw tangent. So when you draw tangent, the way you draw tangent is join these 2 points with the center. This is A, this is B, and the center is O. Join these 2 points with the center. Okay. Now, when you are drawing tangent, the only way you can draw tangent is make a 90-degree angle and join the line, extend the line. Similarly here, make a 90-degree and extend the line. I picked the wrong point, I am not able to put it on the board. I have to pick up a different point. So then, Ananya never called me dumb, okay? I did not mean to pick up this point. I was just not really careful visually. Okay, so I picked 2 points, A and B. Okay, this is my center. Now when I have to draw a tangent, what I have to do is I have to make a 90-degree angle and extend the line. Similarly, when I have to draw a tangent here, make a 90-degree angle and extend the line. These two are meeting here. Let's say these two tangents are meeting at point C, and this is my O. What this theorem says is, the length of the tangent, this one and this one are same. AC and BC are same. And how we are going to prove that is by using the theorem for congruence that we have learned in the past, that this says RHS, right hand side, angle which is right angle triangle, not right hand side, sorry, my bad. For a right angle triangle, two right angle triangles will be congruent or will be exact copy of each other, meaning they'll have all the properties matching if the hypotenuse and one of the side are of same length. Okay, it's like if I asked you guys that okay, Sunarka and Birin are congruent, you guys will not believe that because Sunarka is much younger, I'm much older. One property this mismatch, right? Sunarka will say, oh, no, I don't want to be compared with Mr. Biren, right? Properties are not matching. But when you say congruent, that means properties have to exactly match. Sunarka probably could be congruent with one of his classmates who is of same age group, same height, have similar traits, has similar level of skill. So I mean, again, these are lame comparisons, but still, I'm saying there's a reason to call something congruent. My both hands are congruent. If you look at it this way, if I flip it, you cannot make out that there are two hands, right? If my hands were a little distorted like this, if my one hand would have been bigger and one would have been smaller, then from this side it would have looked this like this, and from this side it would have looked different, right? But now since they are congruent, so it looks like you are seeing only one hand, right? It's overlaying each other. So that's exactly what is congruent. Congruent means nothing but same. It's a difficult English word. It would have been better and easier to say same. These two triangles are same, right? So same thing here. If two right angle triangles are congruent, then, or if there are two right angle triangles where the hypotenuse are of same length and one of the side is also matching, then the two right angle triangles will be congruent. So we will use that theorem. So what we did was, we just have drawn the tangents and we saw it meeting at point C. We have to prove that AC equals BC. And how do we do it? Just join these 2 points. Now what we have done is, we have kind of gotten two triangles. One is this triangle and other is this triangle. So one triangle is AOC, another triangle is triangle BOC. And both are right angle triangles because this is tangent, right? This is 90 degree, this is 90 degree. So both are right angle triangles. What do we see? This is the hypotenuse, which is the same, which is common in both the triangles. So hypotenuse is anyway same. Now OB and OA are same because both are the radius of the circle. Radius is always the same. So one side matching, hypotenuse being common or matching. So this satisfies this condition for this theorem. And hence both the triangles are congruent, meaning every other property of these two triangles are going to match. And hence, if the two sides have already matched, third side had to match as well because they are congruent now. So that is how we can say that this theorem is also right. Did I explain it okay?
Yes.
Okay. Neil, Sarah, Savya, Ritika, any comments? Any opportunity where you saw your teacher going wrong or not explaining it right?